Okay, so for question 2, it says the tide of the Miramachi River has a range of 8 meters. At t equals 0, which represents midnight, the tide is at the sine axis, and at t equals 4, the tide is low. So our time here, it doesn't state it, but it's in hours. Well, it says in A, determine an equation to model the tide after t hours. So first thing I did is I sketched the graph. Okay, so at midnight, so this is midnight here, it's at the axis, okay? So this is like ocean level, okay? And so then the tide goes down after 4 hours, sorry. So 4 hours after 12 is 4 a.m. So that's when the tide is the lowest. And since it says that it has a range of 8 meters, that means that our y will only go, it's only going to be 8 meters from our highest point to our lowest point. So that means that since this is our axis, our sine axis, then it's going to drop 4 and it's going to raise 4. So it's going to, the tide is going to drop 4 meters and it's going to rise 4 meters. Okay, so at 4 it's the lowest, and that means at another 4 hours, so at 8 a.m., it's going to be at sea level, and then 4 hours after that, so at lunchtime, it's when it's the highest and it's 4 meters above sea level. And then after 4 hours after that, which is 16, or if you're doing the military time, or you can say it as 4 p.m. because after 12 a.m., 4 hours after that, that's going to be 4 p.m. and that's when it's back to sea level. Okay, so determine an equation to model the tide after t hours. So you'll see that this is, so our sine functions usually go up, down, and like this. So you'll see that this is a reflection over the x-axis. So it's going to be a negative sign. And then we need to find the amplitude. So since our amplitude is 4 here, that means we put a value of 4. Okay, and then to find out our period, we take 360. And so since it takes for one full rotation, we do 360. So for one full thing, it takes 16. So we do 360 divided by 16, which can give me 45 over 2, or you can also write 22.5. Or 22.5. Okay, this isn't shifted to the left or the right at all, and it's not shifted up or down, so we don't have to include anything else. So that is our equation to model the tide after t hours. So how far is the tide at 5 p.m.? So what it means by that is this is at sea level, so how far from sea level is the tide at 5 p.m.? Okay, we know at 4 p.m. it was 16. So 5 p.m., thinking back to military time, it would be 17. So what we're going to do is that it's going to be 17 hours after midnight. So we're going to put a 17 there, and we're going to get 1.53. So that means that it's falling down 1.53 meters. Okay, so that part is the answer for C. So our tide is going to be 1.53 meters lower than sea level. And then D is when is the tide at least 1 meter below the sine axis? So when is it at least 1 meter below? Okay, and to do that, we're trying to find the time here. So we're going to plug 1 meter into here. We rearrange it, so we got to bring this to the other side by dividing both sides by -4. So then I have -1/4, and I got to bring the sine to the other side by doing sine inverse. So I do that, calculate what this sine is, and then I divide both sides by 45/2. This will give me 0.64 hours. Okay, so after 0.64 hours, that is when our tide is below 1. And then we also need to find, so right here, this to here is 0.64. That means here to here is also 0.64. So 8 a.m. is 8 hours after 12. So we can take 8 and subtract 0.64, and that will give me 7.36. So that means that between 0.64 hours and 7.36 hours is when the tide is below 1 meter below sea level. Okay, you can also change this to the times on the clock. So 0.64, so 0.64 an hour times it by 60 is 38.4. So that means at 12:38.4, we'll get rid of the 0.4. So we'll do 12:39. So we're going to round up because it's below 1. So at 12:39 a.m. and okay, so we know it's going to be 7 p.m. but then 36 of an hour, so I got to do 0.36 times 60. 60 is going to be 21.6. So we're going to round that up to 22. So between 12:39 a.m. and 7:22 a.m., that's when the tide is going to be below at least 1 meter below sea level. Okay,